Are you struggling with productivity in milling applications? Do you have the following impressions regarding a high-feed cutter? I gave it a try, but it's difficult to use because the depth of cut is small. The finished machined surface is too rough. Shattering will certainly occur with a long overhang situation. These are some of the challenges we face when we consider a high-feed cutter.
This is Sujimoto from Sumitomo Electric. Sumitomo's high-feed cutter, SEC Dual Mill DMSW cutter type will help solve these problems. This is an example of a typical cutter type and approach angles for milling. Milling tools are designed with different approach angles depending on the application. The thickness of chips will change depending on the cutter's approach angle, even with the same feed rate per tooth. Among them, the high feed cutter has a small approach angle and can generate thinner chips. For example, a cutter with an approach angle of 15 degrees can generate chips that are 1/4 thinner than a 90 degrees shoulder cutter, making it possible to increase the feed rate. On the other hand, there is a disadvantage due to the small approach angle. Let's compare with other same-side inserts. The less the approach angle is, the less depth of cut in the actual direction. This disadvantage is based on the fact that the high feed cutter is fast, but the actual depth of cut is small. In order to solve this problem, we thoroughly focused on the cutting edge design of the insert and adapted a composite arc-shaped cutting edge on DMSW. The cutting edge design offers a series of multiple arcs which allow us to machine with the optimal approach angle according to the depth of cut and making it possible to use in a wider range than ever before. Compared to conventional designed high feed cutters, not only can we apply this with an ultra high feed that is twice as high as the conventional cutter in a low cut area, but if the feed rate per tooth is 1 millimeter or less, then the maximum depth of cut can be up to 3 millimeters. Let's take a look at the cutting performances in a wide range of areas. First, we will start with 0.5 millimeter depth of cut. This is a general condition for high feed cutters. We will have a 2.5 millimeter feed per tooth with a BT40 machine. As you can see, the DMSW's machining sound is stable, whereas the competitor's cutter is unstable with various high machining sounds. We already have an efficient condition with a 2.5 millimeter feed per tooth, but if the part fixture has enough rigidity, DMSW can machine at even higher feed. The depth of cut is still 0.5 millimeters, but feed per tooth is now 3.5 millimeters. The feed per tooth directly affects cycle time. DMSW can contribute to reduce the cycle time by promoting ultra-high efficiency machining. One point that makes this ultra-high feed rate possible is the thickness of the insert. As shown here, the thicker insert with a thickness of 7 millimeters makes it possible to machine at ultra-high feed rates without insert breakage. Next, we will show different actual depth of cut changes. First, we show 1.5 millimeter depth of cut at 1.5 millimeter feed per tooth, followed by 2 millimeter depth of cut at 1.0 millimeter feed per tooth. Finally, we will show 3 millimeter depth of cut at 0.3 millimeter feed per tooth. As you can see, stable machining is possible with all three different depths of cuts. The conventional high-feed cutter has a limited actual depth of cut, but DMSW can be used in a wider area. As explained earlier, the DMSW insert is very thick and can help provide stability even with the large actual depth of cut. Even at low stability, you can incorporate efficiency by adjusting the depth of cut. One of the disadvantages of the high-feed cutter is the rough machine surface. This is due to the high feed rates per tooth. With conventional designs, uncut portions will remain. With DMSW, the composite arc cutting edge works like a wiper, suppressing the decrease in surface roughness and solving this problem. Here is the data of the machine surface roughness when it's actually machined. Some of the competitors' products prevent the decrease in the machine surface roughness by adding a wiper insert. But this method increases the types of inserts and increases the index timing. With DMSW, the same effect can be obtained with standard inserts, which leads to high efficiency and can obtain exceptional machine surfaces without any additional inserts. Finally, we will explain about chattering, which is a common problem under long overhang situations. It is well known that high-feed cutters, which are more susceptible to cutting force in the actual direction, can be machined with more stability than general cutters. Since high-feed cutters have a high machining load, they are mainly used for roughing and pocketing. Often, we require a long overhang compared to a different cutter design, in which chattering is a common problem. The composite arc cutting edge is also effective in this situation. With this special cutting edge design, the approach angle becomes extremely small when the depth of cut is small, enabling exceptional stability in machining. In this example, we will use a 50 mm diameter cutter on a 340 mm overhang holder, AP 0.8 and FZ 0.65 with an overhang of 7 times D, which makes this a tough condition. While other competitors have large chattering and unstable machining noise, DMSW produces stable machining without chattering. Here, we see the stable machining area of competitor's cutter and DMSW. The overhang is the same, but the result is the machining performance, while the actual depth of cut increases under the high feed condition of 2 mm per tooth. As a result, DMSW was able to machine without chattering with twice the depth of cut of competitor's cutter. This is a helical boring application with a long overhang. Another method to generate a hole is by using a drill, then expanding the hole using a cutter. But DMSW enables high-efficient helical machining from solid without using different tools. Next, we will show the finished machine surface. Deep pocket milling makes it difficult to evacuate chips, since the chips may get caught between the cutter and the wall surface. DMSW has a large pocket design for excellent chip control, which allows you to obtain a good machine surface with less chip recutting. How was the introduction of our DMSW? DMSW is very well received due to not only its high efficiency, but also for its stable cutting performance. For improvement of milling applications, please try DMSW. If you need assistance with any applications, please contact Sumitomo. Thank you very much.